Welcome back. So we are ready to kick things off with blowing stuff up at scale with pitch-perfect attack simulations. For those in the room, after the talk, we'll be doing Q&A. Raise your hand. I'll walk over with this mic. For those on Slack, we'll be taking questions in the Forward CloudSec channel in the thread designated for that purpose, and on Twitter, and we'll ask them on your behalf in the room. Please welcome Rich Mogull.
Thank you. Thanks everyone for showing up today. Now, I have a co-speaker. My co-speaker's on a beach in Cancun right now. I believe technically he is underwater scuba diving, and he didn't want to try to pull his phone out to do the FaceTime from under the water. So to get things started, let's do an intro from Will. We did do all this work together, and we've got some videos of Will presenting parts of this that we're integrating in.
Hey everyone, I'm Will Bengtson. Welcome to Forward CloudSec. Wish I could have joined you there today, but unfortunately I already had some plans. Looking forward to sharing the information. You're in good hands with Rich. And with that, Rich, take it away.
I don't think, looking at his background, that he's too unfortunate that he wasn't able to make it here today. So I have a weird background in incident response. I'm a paramedic, used to be a firefighter on a federal disaster response team. And this will make sense as I get into the presentation. In 2003, I was fortunate to be able to participate in an event called Top Off 2. Top Off 2 was the largest federal national disaster response exercise that had ever been performed. I flew up with my response team. We were a WMD mass decontamination team to Seattle, Washington, where they simulated a dirty bomb attack. At the same time, in Chicago, a different team was responding as they were simulating a bioweapon, and this was designed to test the capabilities from the local firefighters all the way up through the top officials in the Assistant Secretary of Preparedness and Response, and I believe even higher up at the federal level, which I don't get to see that high. And it was wild. We showed up, and they had fake blown-up buses on some lot someplace. They had hundreds of volunteer patients for us. Obviously, I can't show any of those photos. We set up our mass decontamination tents. We put on all of our PPE, level C hazmat, if you don't know what that is. Worked with the local fire officials, worked with one of the radiological teams from the Department of Energy. It was just this incredible simulation that allowed us to test skills in a highly realistic environment that cost millions of dollars to put on. And those skills would come in handy later as I deployed to real disasters, going to places like Katrina, where it wasn't a dirty bomb, but we were dealing with hundreds of patients. At one point, and these are my photos I took from the inside, me and a group of 7 other people had to triage 900 patients in 3 hours. And just things you can't plan for. Things they can't teach you at school. Well, fast forward to Reinforce, but the time when the origins of this conference. And this is when Houston Hopkins introduced me and Will together. Will and I had known of each other, but we had never talked before. Will, if you don't know, has this tremendous hands-on background at companies like Netflix, Capital One. Now he's leading, I believe, all of cloud security over at HashiCorp. My background, if you don't know, is mostly on the researcher side. I've done a lot with the Cloud Security Alliance, with Securosis. We've done a lot of research, and I do more consulting, researchy things, but I don't have the day-to-day operational responsibility, although I have a little of that as I've kicked off a startup and built some tooling myself. And Will and I, for whatever reason, we started talking about incident response. You can tell it's one of my passions. I still do this work in the real physical world, and in the IT world, I just love just not knowing what we're going to deal with. I love the puzzles. I love figuring these things out. But one of the things that I found as I go out there and I do a lot of education, teach at Black Hat and a few other places, is, I'll go out and I'll meet the incident response team, and they walk in the door looking like this. Then I show them a guard duty alert, and it's kind of like this. We know how different cloud is. And one of the biggest flaws that I found, or problems that I found in all the organizations that I've worked with, is that we are really behind the curve in terms of knowledge and education for incident response. Now, by we, I don't necessarily mean this room, okay? This is probably the greatest collection of cloud security professionals that's ever occurred on the face of the planet, or throughout the virtual planet here. But there's thousands, tens of thousands of organizations out there, millions of Amazon customers and Azure customers and GCP customers who are, and apparently there's other cloud providers, but they deserve what they get over there, who are trying to figure out incident response. And I'll go in and give you just a real-world example. I did this great assessment once. We went through, and I dug in, and they had everything set up and all the notifications, and it was set up to go to an SNS topic that was going to feed it off to the incident response team. And I looked at the SNS topic, and I looked at subscriptions, and there was nothing. I said, hey guys, you, the cloud team, you built this all right. Like, you understand, like, those notifications aren't going anywhere. And they go, yeah, we asked our incident response team, and they said they're not ready yet. Per production application. And based on the head nods of the people in the room, you guys see this all the time. So Will and I decided to team up together. And we did this as a combination of a research project and a training class. And the idea was, could we combine our experiences, his very practical, hands-on experience in some of the largest cloud users in the world, my experience on the research side, but also bringing in my incident response experience as a trained incident responder at the local and at the federal level, and combine that together and help pull the industry along or provide materials to help people get better at incident response. And this is what we built. And so what I'm going to do for the rest of today is I'm going to talk about the principles of scenarios and how we built this, and I'm going to go into the tech details of the framework and everything else. But just remember that the overall goal here is that the complexity that Aaron put up there, it's ridiculous. The most powerful thing I got out of Reinforce in 2019 was meeting people like Aaron and Scott and others, and all of us sitting around and trading information and realizing none of us know what the hell we're doing. We are all hanging off the cliff edge by our fingernails. I've got over 10 years of hands-on experience in Amazon, and I can just barely cling to the damn thing and hope things don't collapse. And you know what? It's like the real world. We build all airbags and seatbelts and everything into cars, and the fire department still rolls every day on a dozen car wrecks. So that's our job now, is to be better, to help protect our organizations and understand mistakes are going to be made. We're going to move fast. We're going to break things. Others are going to break things. Others are going to make a lot of money trying to break our things. And it's our job to go ahead and try and make sure that we minimize the damage. So let's talk about scenarios. And this is something this is the parts of things that I pulled in from my experience in my training as a paramedic and a firefighter, mountain rescue, and all this other stuff. And the one thing that I thought we don't really do great, like I teach at Black Hat, and I would throw advanced things out, and I'd throw my incident response scenario out, and we just kind of expect people to figure it all out. And that's not how we learn. That's not how things work. And so the idea was to build series of progressive scenarios to take somebody from that zero to hero, to allow them to build their skills in safe environments. You guys have all taken a CPR class and you practice pumping on the dummies. That's exactly what I have to do in my training as well. But then eventually I get up to what we call mega codes and give you a sense of what those things are. So when we were building these scenarios, as you might imagine, Will and I could probably come up with some really evil things that we could do to people. And we got one or two of those that we built, but that doesn't really help because all it does is show somebody that they're overwhelmed. So the idea is can we build them up? And I like to call these in a couple of areas. So we call it skill stations, then constrained scenarios, and then the full spectrum scenarios. And I'll walk through what those are. The other thing is that when you're starting early in these, you have to be much more guided to your students. The very first scenario, I'm going to walk through it, that we built, that we throw out there when we're running these, doesn't even use our advanced attack framework. It's very simple. Use the CloudTrail event history in the console just to fundamentally familiarize somebody with it, and we walk them through that process. But by the end of the day, we have them doing Athena queries and doing much more advanced analysis piece. The other part is and something that we're not always great at, it's not just enough for somebody to throw a text scenario at you. You need to understand process. You need to understand collaboration. You need to understand division of duties. One of the main things that we learn as paramedics is what we call scene management. There's much higher medical providers out there. There's nurses and PAs and doctors, and you throw them in a car wreck and they are freaking lost because they don't understand how do I manage all the different aspects of the scene safety and getting people into the right positions. It's not just about the patient care. It's about understanding all of the processes, just as I would be lost in many of the things that are done in a hospital environment. And then when we do these things, they can't be so contrived that it won't look like what they see for real. Now, for what we were trying to do, we wanted to be able to scale these simulations out. And scale them out for both dedicated training environments. So we set this up initially to run 60 simultaneous AWS accounts. Where we can run all the attacks simultaneously across those, so every student has their own training environment if I'm doing it in a classroom environment. But the other piece of this is we designed this, as you'll see in a minute, for supporting game days, which is going out in our own organizations and running these scenarios on real resources within our environments. And so there's aspects of being able to scale these that it's not just about running the attacks. Because I started there and I screwed up a lot of accounts, and I have a lot of very angry students calling me up after classes complaining about their Amazon bills because they couldn't figure out clean up all the stuff that I started up in their environments. So setup, attack, and cleanup. The reality is I have spent more time figuring out the setup and the cleanup than I did the attacks. The attacks is by far the easiest part of this. Like coming up with those scenarios and everything else. Being able to set up and then destroy these environments after the fact safely without breaking things that shouldn't be broken was a lot harder. So let's walk through those different parts of the process. So on setup, the way that we decided to do this is every student would get their own account. And the reason for that is we wanted to replicate the whole tool set, give them the start to finish. When people share accounts, they're going to step on each other. And there are times when we steer a bunch of people into an account. So we've only done this a few times with live students, 3 times now. But we'll steer a group into an account. But at the start, we want everybody to look as close to the same as possible. Obviously, ARNs, IDs will be different. And the other part of it is trying to do a multi-account, which is what we all deal with in the real world. I've done multi-account simulations. It's too hard. So if somebody's not familiar with that environment, bouncing between the accounts, that is more advanced. You can use a lot of the stuff I'm going to talk about today to get into a multi-account simulation where one student's dealing with multiple environments. But in particular, dealing with the IAM, dealing with the org level issues end up being just too much. So we focus on single accounts. It is important to get your service control policies correct. If my demos failed today, it's because I screwed up and I moved an SCP off of my main training accounts to do one little fix, and I forgot to put it back, and then I accidentally blew up everything by running my cleaning scripts after the fact. So the service control policies, like I give students full admin access in those accounts. The only thing we protect is the organization account access role, and we protect a couple of other some of the third-party tooling that we've integrated to be able to do notifications and stuff to basically feed the notifications out of the accounts. So that's pretty much it. They can do whatever else they want in there. I didn't get too anal. I did root account protection as well. I didn't do region restrictions or anything else. Make it look real. I can track. I can clean it all up after the fact. It's no big deal. That's on me. The other thing is it should look and feel like a real account. I'm going to show you what those look like, but we put a lot of effort into making these things look like a real. Am I allowed to use Aaron bad words? Or should I keep it clean? I'll keep it clean. Make it look like a real cruddy account that you would encounter in most of your organizations when you let some of the developers and admins play with something for a little bit too long. Now, the other thing is you have to be careful when you set this stuff up that it's not too vulnerable. If you expose port 22 and you want to have some CVE on that instance that can be exploited, it'll be exploited from when you set it up before the student ever gains access to it. And so you got to walk some fine lines there. In a couple of cases, we have students open up ports day of to deal with that. It's kind of funny. I have not been able to trigger the brute force guard duty alert despite my best efforts using my automation. All right, I'm working really, really hard. I finally have somebody in Amazon who's waiting for me to send them stuff to get some feedback on it. Like, how can I trigger this brute force? I'm slamming usernames and passwords against an exposed instance on port 22. I'm running it from my VPN out of Hong Kong, and I still can't get the frickin' thing to trigger. And yet, I set up a class last week, and then I went into the class, and half the students had the brute force alert from China. I was going out of Hong Kong. These were coming from mainland. So clearly, people were detecting this stuff from my setup to the cleanup. So you got to watch out for that. And you also want to make sure it doesn't have vestiges of other things. Even something like somebody's old Athena queries just still sitting in there can mess up a student. All right, now here's the disclaimer. If you want to walk out of the room, I'm going to show you what a lot of this stuff is, how it works, walk through the scenarios. I'm giving away, this is like the Penn and Teller, this is how you do the trick stuff. So if you ever want to play with these for real and not know what they're going to do, now's your time to leave. So in the setup, making it a realistic environment. What I decided on was we're going to go with 3 VPCs, so shared services, a dev, and a prod environment. Each of those, we also turn on CloudTrail, GuardDuty, Security Hub config. Like I tried to do detective, but detective takes too long to like actually work and provide results. We could do access analyzer. You can turn on whatever you want. This was the core for what I'm going to call version 1 of what we've done, because we really are only at version 1. Then I procedurally generated 100 IAM users, 50 IAM roles, 50 custom policies. I'm going to show you what all those look like in a minute, all designed to look real. So these aren't like random text. I actually took name list, things like that to make it look more realistic. So total of about 15 to 17 instances, depending on what runs in the environments, some skill stations, jump boxes, Dynamo Lambda. So it looks pretty much like a real environment that you would see. Now, how it was built was there's 5 CloudFormation templates that I used to go ahead and deploy it, but then those don't work for everything. As you'll see, I'll do a demo of some of the account setup pieces. You have to use code for some of this because we have to intermingle the things we're going to attack with the randomized. So we have to kind of slip in things that look like they're part of the random, but they're hard-coded values. That's what allows us to get in without having to leave like massive vulnerabilities out there. It also means our attacks work well and consistently and quickly. I don't have to enumerate an entire account with Pacu. I know what I need to go into attack. I can use something like Pacu to simulate the enumeration and give people those log entries as well. So in terms of how we did the realism, I used a real name list. I went out on the internet, grabbed it, first initial, last name, just bam, and generated a bunch of those. That's what I call the distractors template. So there's a CloudFormation template. Yes, I built this with somebody from HashiCorp, and it's in CloudFormation because not Terraform, because I had some stuff already to reuse. And we're having that discussion, and I'm a little embarrassed about it, but it is what it is. So we built a distractors template, which builds all of the things that are those. It's hard-coded. It's fake users, fake roles, whatever. And there's some interesting stuff. Like I would take Amazon managed policies. I would then duplicate it, and then I would reload it with a new custom policy name to look like a customer managed policy. I learned that Amazon has some managed policies that are longer than you are allowed to have your own policies. So I had to start doing byte counts, character counts on those because my script kept breaking. I'm like, oh, I'll exclude this one. Oh, I'll exclude this one. I'll exclude this one. Okay, I actually have to do the character counts now because it would keep breaking those things. S3, I try to put that in the CloudFormation templates. It worked great the first time. This is me being a frickin' idiot. I know how S3 names work. I know you can't put S3 names into CloudFormation templates if you're going to run them across 60 accounts simultaneously. And so I had to go through and just write Python code to create the S3 buckets. They're the distractor buckets. And then, so I ran it once, created that template. You can actually see the name list here on the bottom that I use. Roles are named after environments and app names, and kind of really just made a best attempt to make all of that look as realistic as possible. Now, if you're going to use this in your own environments for like a game day and do something similar, do the same thing. Don't name it InfoSec IR Response Test 1 through 6. Give it names that will match that environment, but use hard-coded values so that you can go through and clean those things back up after the fact. You definitely don't want to be leaving a mess there. So ignore the build order on this slide that I forgot was on this slide. So the setup process in terms of doing this is first I would deploy the infrastructure as code template to set up the CloudTrail, GuardDuty, get all of that up and running, Security Hub. Then set up the infrastructure. So the infrastructure template is the real stuff. So that is so each stack we have, dev and prod, is a load balancer, autoscale grouped application connecting to a Dynamo database. So that's set up all properly in those templates, the shared services, what I call the skill stations, which I'll go into in a minute, what skill stations are. All of that is hard-coded into those templates. And then I layer the distractors on. So that's what makes it look more like a real environment, is all the random naming and CRUD naming that we all have had to weed through as we do assessments or do our own projects. Then I run the app, which does the setup. So right now it feeds in with a CSV file of all the account stuff. And then it just assumes the role into each account, sets stuff up, and then also it runs simultaneous sessions, 1, 2, which I didn't even know you could do. I'd never tried to do 2 simultaneous sessions in the same app before. It works fine. So one session in each account that rotates through the assume roles, I'll show you those. And then the next session connects up just to store our credentials on the attacker side. What we do is basically that code connects into the account, creates the resources that we need. That's generally going to be an IAM user with an access key, maybe some S3. Everything else is hard-coded into the infrastructure as code templates. Makes it much easier to deal with. These are the one-off setups. And the reason for that is we need the access key and the secret key, and we load that into Dynamo. That's our leaked credentials way that we get in. There are other attacks we do where we do extract the credentials. Not every attack is a leaked credential simulation where we just have a copy of the credentials. Some of the attacks that you see, like we do a SSRF attack, where we actually have to go through and extract the credentials. Now, to make our lives easier, we're extracting a hard-coded value with the permissions that we need ahead of time. But again, that doesn't affect the realism of the scenario. But you do want a combination of those techniques when you set this up. Because earlier kinds of simulations I was doing on my own before I paired up with Will, everything was kind of hard-coded. Everything was really easy for the students to figure out. If they wanted to cheat, they would just look for the stuff I created at a given point in time. And so that's why we went through this much more complicated process to set up the environment. So I'll pull it up just to give you guys a sense of what that looks like. Yeah, I'm in one of the accounts right now. So if and I did it all in one region for the most part. And so you can see that we've kind of set it up. It looks like something you might drop into an account with some hard-coded names, the autoscale group stuff. These things like IAM test and logger, those are what I call the skill stations. We're going to test a single skill on those, but they're not going to be part of any of the attack scenarios, the larger scenarios as part of that. But the main area where we do the work, because as you guys know, every cloud failure is an IAM failure, and every IAM failure is a governance failure, is over on the IAM side. So, good luck figuring out which of these things are the... Well, you can because, based on the active key aids. But that's actually something I should do to enhance. I just realized. That's just too clear right there. Okay. You can see that we created, these 100 users, roles, policies, everything just to make this look as real as possible. In terms of what the code looks like over here, make sure I'm in the right one. Yep, I am here. So I've got my setup directory here and generate attack resources. And let me make the text a little bit bigger so you can see it. One of the other things we try to do is any of the actual things that we're going to use to exploit, we try and use realistic looking policies. Don't give everybody admin everything. Don't cheat and use power user on all of these. Make it a policy that is going to be, have something like in this case, I've got pass role and I have run instance. So everybody in this room knows what that means. But in a training environment, they may not know what that means. And these are more realistic in terms of the kinds of ones that they're going to encounter. And so the core of the code here, nobody's here to hear me read code necessarily, is, here's all the environment stuff. And then as we actually go through it, just set up all the various users and store those credentials over in Dynamo. So that's the setup piece of that. Let's go back to the slides. Then we get into the actual running the scenarios themselves. So the first is that there's these different levels of scenarios you're going to have. There's going to be skill stations, focus on a specific skill. Very, very simple. We've got one for how do you contain a compromised IAM role. That's a skill station we set up. There's 5 to 7 different ways depending on what you're doing, and we set it up to show them the ways it will break applications. And so we walk them through. If it's set up as a Bodo session, you're going to break your app if you use many of our standard quarantine techniques, and then we teach them how to go ahead and insert a service endpoint and then set up the VPC ID rule kind of a thing. It's just walking them through those progressions. And then you move up to the more simple scenarios. This is us laying it out in front of them, but sitting there as a proctor and then walking them through it. So I'll show you one of those. We'll actually do the example. It's a public S3 bucket. You found the public S3 bucket. Now how do you trace the activity back? Much more of a guided situation, much more of a constrained scenario. because then we get into more the mega code. This is we're running our live attack code stuff. You're getting alerts popping up. You have to collaborate with others. It's meant to look like a real live attack. That's when I hit my VPN up and start coming in from strange IP addresses. That's when we play those larger scenarios. And then game days, which is the actual running this for your own team internally as opposed to running it on a training environment. Set up a game day to do your internal, and the game days are much more of the mega code CTF style than it is the skill stations. So again, skill station, specific skill, highly constrained. You still want it to look realistic. You do want to not make it so constrained that it doesn't look like anything. And so 2 examples. One is that I'll walk through setting up a misconfiguration, and then they have to trace that misconfiguration back. Because a very large percentage of what we do in IR, it's not attackers coming up with strange new ways to exploit Lambda functions with O-Day attacks. It's somebody screwed up and made an S3 bucket public. So how do you just trace that back? You'll deal with many more of those than Lambda O-Days in your career. But then we also need to show the attack side of it as well. That's one thing I think that is a little bit different for cloud than when you've run some of these things on premise. I found that I do much more of a misconfiguration, accident focus, and how to communicate with other teams, because that's a very large percentage of our incidents. It's not just really the attack-based stuff. That's a lot more fun. Then another example is containment, how to do the IAM role isolation, how do you isolate a network connection. These are designed to teach these baseline skills that they're going to need before they can go any further. Then we get into the full scenarios. There's obviously a spectrum. I showed you the stuff I did at Top Off with fake blown up buses and explosive debris scattered around some, I don't know what that was, a construction site, however they set that up. That's great. That's you know what you're doing, you've got a lot of experience, let's go there. Or sometimes you'll do those advanced scenarios deliberately to overwhelm somebody just to give them that experience and help them kind of focus on their training to get up to being able to handle something like that. But the other side of the full spectrum is it's a real scenario. It's just not all that complicated. So it should be progressive complexity. And the full scenario, the difference between that and a skills station, full scenario should show the path from detection to recovery. So you detect, you analyze, you contain, eradicate, and recover. The whole incident response process should ideally be part. And maybe your recovery, you just make that part easy. You chop it off at a certain point. But and then you also will typically have discussions and post-incident analysis around this as well. So there's a lot of different cool techniques you can use to make these scenarios more realistic. Launch stuff from Tor, launch it through VPN. Early on, one of the things I asked Will was, I go, okay, you deal with way more real attacks than I do on your environment. What percentage of them originate from Amazon's IP address space? Because I was thinking, I'll just run these attacks as Lambda functions or something in an account somewhere. And he goes, none of them, really. Almost all of them are coming from outside AWS. Okay, that changed our architectural decisions so that we could replicate that. We'll go more into that a little bit. The IAM policy thing I talked about. Don't just give full admin or super user, power user access or whatever all over the place. Make the policies look realistic for the role they're being assigned to. You can still put in your privilege escalation flaws and everything else, but that gives that student or that employee the time to figure that out, the opportunity to figure that out, instead of just going, oh, well, you had full admin, so of course you could do whatever you want in my account. We don't use the org account access role to launch any of the attacks. We don't use our external admin access to launch any of the attacks. Everything has to be pre-built and structured in those environments. Then, simulate reconnaissance. Simulate enumeration of the accounts. So you'll see in some of the ones that we'll go through and just do bunches of describe calls before we execute the actual real exploitation call to go in, because that's what it's going to look like in the real world. The attacker is going to have to do a little bit of reconnaissance. They're going to test the privileges of a lost access key, or they're going to look around for an S3 bucket for them to compromise. Now, you don't have to be completely realistic about those, and actually, we still use the hard-coded values, and a lot of that is for resiliency of our attacks to make sure they work, and we're still giving a good student experience or a good training or a game day experience. But you want to make sure you do the enumeration. You just don't laser right in and show no signs or symptoms. That's why I'm really frustrated. I can't get that SSH brute force to trigger, because it's a really cool attack. It's like you brute force SSH to a jump box, and that has SSM, and then you push out a cryptocurrency miner to all the autoscale groups over SSM. And the students are hosed right now because they see the cryptocurrency miner alert in guard duty, and they can't trace it back really well, because the brute force never shows up. So finding that point of entry is a problem. Those are the kind of things that you really want to think about as you're building out your scenarios and testing your scenarios. And the last one is containment constraints. Do we just get to terminate stuff for real in our workplaces? We don't. Well, some of you might. And are you hiring? Because for the rest of us, we frequently don't. And so how are they actually going to go through the containment process? All right? So as a medic, I'm not just trained to like drive with lights and sirens, show up, look at the patient, go, you're going to die soon. Cool, we're done here. And then like go on to the next one. You actually have to go through and do the whole treatment and containment and the cleanup process after the fact. So this is the architecture of the core attack framework that we built, and I'm going to walk you through it, do a little demo, keep track of time here as well. So basically, we have a dashboard. Will's going to do a video about how the dashboard works in a minute. The dashboard has all the info to get into the accounts, as well as it allows us to go ahead and do assume roles into there. When we launch an attack, that goes into an SQS queue, which hooks up to a bunch of Docker containers. The Docker containers will connect up to Dynamo, pull out whatever credentials they've been assigned. So the attack message is this account, this attack, this username. It's just those three pieces. The back-end attack part of it, and the containers we can distribute anywhere we need to as part of all of this. And then the actual container will go ahead and execute that attack. So let's go ahead. Will's going to walk through the attack portal, and then I'm going to show the rest of it.
Rich and I spent some time building out various different attacks that we thought mimicked some real-world scenarios and that we wanted to put in front of people. But we really wanted a place to make it really easy to launch those attacks from, as well as get into accounts to help students if they need. And so what we decided upon was building a web portal, and that web portal should be able to reliably launch attacks, and it could be launching them per account, all accounts. But most importantly, we also needed a way to help us get into the accounts of the students so that we could make sure the attacks were executing properly, as well as help them through the scenario should they get stuck. So we went ahead and built this simple bootstrap web portal attack dashboard. We were able to load the accounts that we were working with. So we can see here we have a list of accounts with the account name, root account ID, the account ID from AWS, and of course a button that can do the federation to log us into the said account to be able to poke around, as I mentioned. And then up top we see we have an attack drop down where we can select a different attack that we've chosen for the day and click launch. So if we look at what that might look like, you can see here we've selected 4 accounts. In the attack dropdown, you can see some of the attacks that we've developed, making public snapshots, sharing AMIs, triggering canaries, etc. So you can select an account from accounts from the list, and then select an attack and click launch. When you click launch, behind the scenes, it's understanding which accounts you've selected in the attack to launch, and it's scheduling those attacks through the attack queue. And then the attack workers are draining those messages in launching attacks from wherever the workers are running from. So what we found is as you start investigating and giving folks Athena queries and getting them to understand the initial indicator of compromise, they start to see, once they have an initial clue, and try to figure out, okay, with that indicator of compromise, what else happened? And then you walk them through one attack, and what we found is on other attacks, they start doing things like, just tell me everything that happened with that previous IP I knew about. And so it was really important for us to be able to run attacks from anywhere. So when Rich and I first ran this, he's running from his house, I was running from mine. So then we started launching from Ukraine, Russia, DigitalOcean, droplets. We just started bouncing attacks from everywhere to really simulate a skilled adversary, but also prevent situations where someone is able to run something like this and cheat, not cheat, but skip some steps and come up with the answer. And so we came up with this attack portal, which I thought was pretty helpful for launching the various attacks. Most definitely was helpful for us bouncing around through different AWS accounts to help students and debug problems where we had them. But looking forward to expanding this in the future.
And so I walked over through the architecture piece, and I'll show you guys what it looks like, and we'll get it up and running, and then I'll launch an attack here in a bit as part of the scenarios. So first, these are the Docker containers. I've tended to run these locally and then just do a VPN in. So I use iVPN, and it's kind of cool because I can simulate attacks going to anywhere. So let's change it and go to Ukraine. And now all the attacks are going to go ahead and originate from over there, assuming my internet connection stays stable here. Let's go ahead. We'll launch a couple of the containers here and get these things up and running. Now, the nice thing is that we can, like he said, we can run these anywhere. So when we realized the students were tracking in on us because they figured out our home IP addresses, I threw on my VPN, and then Will just started dropping them over in DigitalOcean and locating them in different geographies. And then the students that was more confusing for the students. It also more replicates kind of the masking that a real attacker would go ahead and do. Now, on the AWS side of this, if I go out of the training account, I go into the master management account here. Basically, it's an SQS queue and Dynamo database. So that is the controller pieces on the back end. Nothing fancy in terms of what we're doing in the queue there. And then the Dynamo database will go ahead and is where we keep the username, access key, and the secret key. And the network's running a little slow, so I might skip through some of the demo pieces of this. But let's see if I can at least show this part of it here. Just, again, nothing too fancy here. I don't care that people are seeing this. This is going to be wiped out, after I walk off the stage. But that's how the hard-coded values that we use to go ahead and get all of that up and running. And then the attack dashboard itself, so we'll show a few screenshots. I'm going to go ahead and, if I find my right screen here, okay, let me go ahead and launch it. It's still my virtual environment. And then I'll go ahead and scroll this up here and hit refresh. And so this is how we keep track of it. So we've got our the account IDs, the emails associated with it. And then if I click on any of these, that'll go ahead and just bounce me into the portal as well. So that became a super handy feature for us to be able to go in and, well, that normally works. Hey, live demos. So what are you going to do? Super handy feature. And then we just click which attack we want based on what we've loaded up for the day. Execute that. That goes into the queue. That hits the containers, and Bob's your uncle. So, and I'll actually go ahead. One of the things that we learned is attack timing is really important. Like, it takes time for some of these attacks to run. So if I click, let's do the privilege escalation. So this is the put roll run instance kind of a thing. Oops. And I actually just screwed up in a way that will break things. So let me go to SQS really quick and purge the queue because I put an empty message in there, and I discovered last week if we do an empty message that will go ahead and break it. So we'll go over here, the search, yeah. Anybody else hate the new console as much as I do? Yep, because now I have to scroll through and remember where Simple Queue Service is hiding in here. Top right. And I'll go purge the queue really quick and then restart those containers. The other things you learn is if your attacks are really short or really long, make sure you set your message times right in SQS because it may time out on the SQS side before the attack is finished, and it'll send the same attack to somebody else, and you'll get the multiple attacks run from different containers because you've got the TTLs that are not set properly. So, quick purge there. Okay, so now we go back. I've picked the account I want to run the attack from, and then I'll go and launch the actual attack. And then just to be safe, I'll do just another simple one here. Let's go with a public snapshot. Pick the account, and I can pick all the accounts, none of the account, or some of the accounts. Obviously, as I showed you, if I pick none of the accounts, then things break. We'll go back to Docker, It looks like the containers are up and running, and just to be safe, I'll run another one there. And so now that attack is executing in the background into that environment. So we'll go back to the slides, and we will come back to that piece. Any questions on the architecture? I know we'll do the microphone stuff later, but there's some enhancements we definitely want to do that I'll get into as I talk about some of the tech limitations. But the real meat and potatoes of this is designing realistic-looking attacks and actually designing the different scenarios for the students to go ahead and run through. So the first example here, this one, we don't even use the attack framework. It's actually done by a CloudFormation template to simulate an admin screwing up and overprivileging in an environment. And in this case, we start over at Security Hub. There's a public S3 bucket finding. They go through the event history, and then they have to start pivoting and gathering all of the different details and the information, just like we would have to do in a real environment. I start in the CloudTrail event history to give them the basics and to also show why you will never, ever, 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 ever use the CloudTrail event history to investigate anything for real, because you can't get the information out of it that you need to, as we all know. So it's a good start, but it definitely, to teach some of those foundational principles. And so that's why, that's that whole skill station concept. So if I go in, and you know what, for time's sake, I'm not going to walk through the demo of what all of that looks like in the account, but, and a big part of it is also teaching the students where they run into walls. Is it another account that you don't own? Well, then you got to go to Amazon, or you got to figure out who owns the account. Those are the kinds of things that need to be part of these. Now, skills are, a lot of it is to teach the basics. One of the things that I found is that, the whole Barney Fife thing that I had up there before, they don't know where to start analysis. These are smart people who know how to respond to incidents, all right? They're not idiots by any means of the imagination. They just don't know what they're looking at because they have not done this before. And that's why these skills can really build up that capability and that confidence. Prioritization of analysis. We always start with IAM. When do you go to a resource and actually start looking at the resource itself? I call it stop the bleed. Is this you need to fix this problem right now? Or are you going to get tunnel vision if you go down that pathway and do your forensic analysis of an instance by imaging it? Shouldn't you focus on the IAM because that user got in and managed to do a privilege escalation on the IAM side? So it's all the prioritization. So we have kind of a cheat sheet that I could show you. I mean, it's just first you look at the IAM, you figure out if it's an admin, you see if anything is public, and we walk through a whole prioritization scheme around that. How do you look in CloudFormation to see these mistakes? How do you avoid the distractors, which is huge? I had people honing in on the API calls made from our external monitoring tool that we use to send the alerts out, because that was firing off a whole lot of stuff on the same resource that we were simulating the misconfiguration on. So they were honing in on the security tool. They weren't honing in on the source of the breach. That's why if you're going to do this as a game day as well, you want to make sure you're doing this as realistically in your own environment. And then you get up to the full scenarios, where you're actually doing the soup to nuts, and these tended to be more attack-based. So the top part here in the center is we simulate the recon, we find the target S3, identify an instance profile, do run instance put role. That's the one that I had launched a little bit ago that simulates that. Embed a bash script in the user data field that copies S3, then images the AMI, or creates an AMI out of that instance, and then shares that AMI either publicly or with another account. I can't remember which way that we had it set up for this. And that's a real scenario that we've encountered on real incidents that other people have seen, using AMIs for data exfiltration, using privilege escalation. And in this case, the cleanup is pretty easy because the user can just kind of clean it all up. Others, like our SSRF, that's a running production application with a compromised role, and we set it up to make it hard for you to go ahead and actually clean up that piece of it. And I'll show that in a minute, but I want to switch over to Will talking about game days before I switch back into the scenarios. Because this is where you take everything I've just talked about and you run it on your own team and you run it internally and you run it on real environments if you can.
Let's talk game days. What are game days for? To me, game days are for avoiding this situation. Deer in the headlights. They're to get you comfortable with responding to certain events, unknown circumstances, and potentially not enough data. And when we think about game days and trying to avoid this deer in the headlights look, what we're really trying to do is decrease how wide your eyes are each time. Get you comfortable to processes, responding, sources of truth, access to data, and what we're going to do is see that you can do so in 3 different ways. The last way, ideally, is what we like to avoid, but the 3 game day scenarios that I like to discuss are simulated environments, real environments, and then go time. The simulated environment game day is real-world scenarios with somewhat similar tooling. You're taking a step into an environment that you might not be familiar with, that you're having attacks launched against, and then you're trying to understand, can you do the investigation that you need to determine what was the indicator of compromise and what happened from that scenario. Then you have real environment, where you've gone and launched these attacks into what you're used to. You could be planting things on instances that are running certain applications. It could be a simulated leaked credential being abused, but you have a familiarity with the environment that situation's running in, the investigative tooling that you're used to, and ideally some playbooks that are framed around the scenario. And then you have go time, which is learning on the go. You have an incident or an investigation that needs to happen, and you're having to understand where you have gaps or where you have visibility in order to do the thing that you need to do. You, of course, have the tooling that you're used to for searching into logs and access to various environments. But, as I mentioned, this is the wrong time to be learning as you go. And so ideally, you've already done some game days in either a simulated environment or in your real environment. When looking at game days, you typically have a writing team, in this case, myself and Rich, where they're coming up with a scenario for a given set of people on the adventuring team. Some faces you might recognize, Scott and Anna, of course, of Forward CloudSec. And you're ideally trying to come up with a scenario that's going to be a learning experience for all parties. So it could be that it's a scenario for just a single team, or there's multi-teams involved, so like cross-function. And so you're ideally writing a scenario where you have assumptions of how teams will respond, what potential gaps there are, and some presumed outcomes. But ideally, you're developing these environments that all teams can walk away learning something, and ideally have actions that they can go build upon after the fact. So if we dig a little deeper into the simulated environments or the game days, we have simulation environment game days, where you have attacks like SSRF credit exfiltration, publishing snapshots publicly. You have some canary tokens being triggered, and more and more attacks. And then you potentially have detection engines like GuardDuty or StreamAlert, where we've written some one-off rules, or you're relying on GuardDuty anomaly detection to help you. And then you have investigation tooling. You might not have your Splunks or Elastics or Sumo logic, but you have things like Athena or CloudTrail event console to do some initial investigation. When you think about real environment game days, you have the same types of attacks that can be run, but most importantly, you have detection engines and tooling that you're used to. So you might have GuardDuty deployed, StreamAlert, or written some custom tooling and detections. And then you have the investigative tooling that you're used to, be it Sumo Logic, Splunk, Elastic. You have automated enrichment, and then once again, just processes and playbooks that you're used to, so you're a little more comfortable. And the real environment game days are really going to help you identify the visibility gaps and logs and what you're capable or not capable of detecting. And then, of course, the one we want to avoid, go time. You'll see that this is the exact same as the real environment game day, except you're having to learn on the go. These are scenarios that you potentially haven't predicted. Some common things that I'm sure some of us here have had to go through are responding to situations like CodeCov or SolarWinds, trying to understand, do we have this in our environment where we impacted things like CVEs? Once again, are we vulnerable to this? Where in our environments does this exist? And then, of course, the response. Let's roll everything, let's patch.
And then we get to the hardest part, which is the cleanup of these environments. I'm not going to walk through how difficult this was. I had to write custom scripting for Amazon Nuke. We had to go through and particularly because of S3, there's so many ways Amazon doesn't want you to delete anything out of S3. Like, it becomes absolutely ridiculous. So Nuke didn't work completely, wrote my own custom cleaner, used that custom cleaner in combination with Nuke because you never know what somebody's going to do in that environment. If you are running this in a game day or a real environment scenario, you absolutely need to hard code your cleaning. And you need to be very clear with your teams and the parameters so that they don't do something to break that real environment that they're running in. Now, it's probably going to be dev. I don't know anybody that really does much of this stuff in production, but you want to make sure that all of those values are properly hard-coded and you have a cleaner to sweep through and automatically clean all of that up. If you rely on manual cleaning, it's just going to go ahead and be a nightmare for you. And so these are just some of the tech stuff, and we're a little low on time, and I don't think this is the most interesting part here. So what are the lessons that we learned? Well, one is I've learned the hard way that setup and cleanup need to be distributed, and I've learned that stack sets suck. So they're not meant for this. They're meant for other things. They're not meant to be, the reason that a lot of that breaks is once you start utilizing resources in that environment, a lot of the CloudFormation stuff can't pull it out, which is why I had to use a combination of CloudFormation deletes with manually cleaning things, particularly because of S3. The other thing is, while we scaled our attack architecture, I thought the setup cleanup would go fast enough. I didn't need to scale that. No, I was absolutely wrong about that. So I'm now moving the setup cleanup stuff to running containers because it takes too long to run as Lambda functions, to run them within, or too long to run for any reasonable cost within Lambda functions. To run those things in containers, we're going to move to a distributed architecture for managing and cleaning up those accounts. And the other thing is error handling is important for attacks. It was just a few days ago I realized I launched an attack without setting the account, and we just missed that. We hadn't tested it. We didn't run that in any of the previous times that we were using the attack framework, and that broke all the containers because they were getting a message without the account ID and the other details specified. It was just a screw up. Very easy to fix, but you want to make sure you run that kind of testing as well. Know your attack timing, as I talked about. Make sure you have backup accounts if you're going to run this. If you're doing this as a game day in a real environment, have some pre-built training environments as backup so you don't waste everybody's time when somebody goes and fixes the thing in the production environment without telling you about it. If you're running this in training environments, that are isolated training environments like I've been demoing today, same kind of a thing. You want to make sure that you have backups to move people over to because some stuff's going to break. And then the attacks, you got to have that good mix in AWS, outside of AWS, moving IP addresses. Try to do that in a logical way. Like, we don't randomly execute all the IP addresses. We might want the students to hone in on addresses from a particular location to kind of trace those parts of the attack back. But all that has to be in there. And then simulate collaboration, communication, and process as well. And look, I've done these things are so much fun. I've gotten to do crazy things like innovate and level A hazmat suits in the real world. Building this attack framework that we did was probably the most fun thing that I have built in years, just because it was so much fun. Like, how do you do a real SSRF attack? Will had to write an SSRF vulnerable application, and we had to hide the credentials on it, and then we had to enumerate it so we'd actually find it like any other outsider would. So it shows up all correct in all the loggings. Like, it's cool and it's fun to come up with those kinds of things. But these are skills that you're going to end up using in the real world. When I, in 2005, was doing, and 3 and 5, doing all that hazmat stuff, I had no idea that we were going to come into, a COVID environment, and I was going to spend 2 weeks in a COVID hot zone, having to wear my PPE and not make any mistakes. And I didn't make any mistakes, and I tested negative, and I went home to my family, and this is long before vaccinations and everything else. Anyway, I thank you all for your time today. This stuff is so much fun. Come grab me, ask questions. I'll tell you everything about how we all built it. I have some of it that's releasable, one piece of it that's already released. Not everything is ready for prime time release, so I can't put the whole framework out there. And that's it. Aaron.
Any questions in the room? I'll start with one from Slack. So you mentioned a checklist for questions during a response. For example, how to prioritize analysis to make sure you're not breaking something critical.
Yeah.
Can you sort of give us some highlights or share that list?
Yeah, so I definitely will share the list out, and I'll throw it into the Slack because that's the best place for it. The biggest thing was when you're doing your analysis, there were two concepts. One is I call it the sick, not sick, which is, how bad is it? And then the stop the bleed, which is this something I need to fix now? So public S3 bucket, we teach, or I try and work with people, it's like, you need to make that not public right away. And then you can come back to the rest of your analysis and figure out the attack origins. In other cases, what you'd want to avoid, though, is like doing forensics on an instance when that attacker's already gone into the management plane through some kind of an IAM compromise. So I'll put the list out, and it's just kind of honestly, it's something I did but never thought about until I had to teach it to people, and I'll just share that out.
Cool, thanks. And a noob question from AJ. What is it that run instances and pass roll actually do when they're combined?
Oh, yeah. So if you don't know, so the way it's set up is if you can run an instance and you can assign that instance a role and there's no resource restrictions, that allows you to run an instance, assign it like an administrative role, and then you can log into that instance and now you're an admin. So that's how you can escalate privileges. It's so bad that if you actually go to do this, so manually build IAM in the console now, sometime like 6 months ago, Amazon added a warning. Anytime you do pass roll with no resource restrictions, there's a little red flag on the bottom of your screen.
And one more question, which is how do you calibrate this range for different kinds of users?
That's the toughest thing, and that is a wonderful question. So Will and I premiered this thing at Black Hat, and it tended to be a more, obviously not everybody's like a Black Hat, but they tend to be more technical. I did a class last week where some of the students, out of 16, like 3 had incident response experience and like 3 had cloud experience, and they were not the same 3 people. And that became very, very hard. So I switched gears. At the more live environment, we were throwing the attacks out, we were making them collaborate, they were all having to figure stuff out. With them, I used the same attacks, the same scenarios, but I walked them all through it. So I turned that into me putting the students on a leash and telling them what to look for and them looking for it, because they didn't know what they were looking at all. It really was beyond them. And they didn't know how to respond. So I led them along. Same material, just changed the style of working through it.
And one more, have you run into any issues with AWS's abuse staff while doing these attack simulations?
No, I haven't, because we constrained everything to, we hit hard-coded values and stuff in ways that aren't going to trigger anything or shouldn't trigger anything on the Amazon side. And if there is a problem, rumor is Amazon knows who Will and I are and have our emails and phone numbers, so they can come to us. Like, I think somebody asked, like, hey, do we need to know about anything you're going to do at Forward Cloud Sec, for the demos, which I ran through, probably a little too quickly here. Yeah, I mean, the attacks ran. It's just I don't have time to show it, so you can hit me up afterwards. But it should not trigger any of those pieces. I have had problems with that previously with things I've done. This time we haven't managed to cross that line.
Yeah, 1 second.
What's this going to cost for these? What's the rough range, rough estimate about using an environment and economic, what's the overall cost?
Yeah, so I haven't done it on per account. For 20 accounts, 3 days, it's costing me a couple grand to do that. And that's dedicated training environments. And the thing is when we do those, the customer or whoever we're working with pays for it at that point. If you're only running this on like a single account and not 20 simultaneously, it's not too bad. It's 15 instances, and then everything else is practically free tier still. Yeah.
Cool. All right, well, we'll take a 10-minute break, split into 2 rooms, 2 streams. Up next, we've got operationalizing AWS Guard Duty and the enterprise cloud journey. So we'll see you there. Thank you very much, Rich.
And here's the alerts for the attacks. I just didn't have time to show it while I was speaking, but they all were popping up in the background there.
Cool. Thank you.